All right, let's go through question 3. So question 3, it says we need to prove whether each of the following have one or more solutions for x. I might be thinking, well, how can we do this? So first, let's think about what we can do. So we have 3 minus k e x minus e to the power negative x. So we know this is our inverse. So we know this will be 1 over e to the power of x, right? Equals 0. And now to make this equate, have the same denominator, we multiply the top for each of them to e to the power x. So we have 3ex minus ke 2x, because when you multiply two indices together, they add, right? So you have minus 1, and that will just equal 0, because that whole thing will be over a fraction. So you multiply ex to both sides, and it'll just give you 0. So now what I'm going to do is a common method, and it's called substitution method. So I'm going to let ex be a common numerator. That is, let it be a. Yeah. So then now we have 3a squared. 3a minus k a squared minus 1. Yeah. So that's equal to 0. Now, what can I do next? And the next thing that I can do is I can make this so that it's ka squared minus 3a plus 1. Yeah, because I'm just putting it as quadratic. And now we need to find out when it has one or more solutions for x. So now I have to think, well, how can I do this, right? Yeah. So then to solve for this method, what I have to do is I have to use the discriminant. So b squared minus 4ac is greater than 0. Yeah. So then I know that b squared will be 3. 3 squared minus 4k times c, which is just 1. Yeah. So then now I know that negative 4k is equal to root negative 9. Yeah. Because I just minused it by both sides by 3 squared, which is just 9. So this will give you k equal 9. So now I have to divide both sides by negative 4. So k, because I'm dividing by a negative, the signs, they switch. So it'll be 9 over 4. Yeah. So therefore, k must be less than 9 over 4 for it to have one or more solution. Yeah. Or it can equal k equal 9 over 4 for one solution, and for many more than one solution, it will equal this. Yeah. So put it as greater than or equal to. Yeah. Smaller than or equal to, sorry. Yeah. So now this is where I have to begin. So let's go question 4. Question 4 here. It says show that s equals 7. So I'm going to break this down. And I know that the value for b is 0, 7. And for this here, we just need to make one value equal to 0. Yeah. So 0 equal to p 0 squared to cube plus q 0 squared plus r 0 plus s equals 7. Yeah. So therefore, s equals 7. Yeah. And we've just proven it. So therefore, we have proven s equals 7. And that'll give you that 1 mark. Now the next mark is you have to find out that r is actually equal to 4.25. So you start by dividing it, the original equation. Yeah? So we know that we multiply the power, so that's 3 p squared as the power decreases by 1 plus 2q, the power decreases by 1 again, so that's x plus r, right? Yeah. So then now therefore, so we know that f negative 0 equal to so that'll be x squared there as well. Yeah. So that'll be 3p0 plus 2q0 plus r equal to 4.25. So therefore, r equal 4.25. Yeah, and we have just shown that. Yeah? So the last statement is always critical to showing that you understand that question. Yeah. So now we need to use this information to find Q in terms of P, right? Yeah. Yeah. So then let's go to the question for the approach that I had, and we'll go through it together. Yeah. So this one, for question BII, you need to differentiate it. Yeah. And then after you sub in the value for A, it'll give you this. Yeah. And if you sub the value for Q and R that you've already solved earlier, what you can do is you can find the value for A equals 17 over 12p, right? Yeah. And then this question, if you have a subsequential value, so if A equals 17 over 3, then you can sub it into all the other values for the given equations to find out that P equals 0.25 and Q equals negative 25. Yeah. Yep. And that's it. That's all for question number 4. And question number 4, all you have to do is you just need to find the x-intercept coordinate for D. Yeah. And that would just be the x-intercept. Then you can use integration to find out the area within that spot there. Yeah. And that'll be all for Maths Methods Exam 2 separator questions. Yeah.